Questions on the homework. Let's start with this first. Questions on the homework. Okay, I heard I'll definitely go to the challenge. That's fine. What
7,
number?
8, 9, 10.
2?
7, 8, 9, 10.
Oh, can number 2.
Okay, let's take a look at 2.
7, 8, 9, 10.
All right, relax, guys. One at a time. What do we got for 2, Derek?
You got, it's basically, you gotta divide by, you gotta find the greatest common factor.
Guys, he's not talking for himself. Come on. You got to divide by the...
I said you gotta find like the greatest common factor.
Good. In the bottom, what's the GCF?
I got 5.
Looks like 5, right?
Yeah.
Well, what about 15? Isn't that both of them 2?
Yeah, 3. What? I divided by 3.
I understand what you're saying. I understand what you're saying. So here, if you were to take out a GCF, it would look like this. It would be a 15, right? Now, what Derek is saying is, well, I can really just pull out a 3, because up top, all I can really reduce by is 3. So that's fine if you want to do that. But when I see 9 over 15, what does 9 over 15 reduce to?
Our schedule should begin at this time.
What does
Thank
9
you.
over 15 reduce to? 3 over 5.
Yeah,
So in the end, you still get 3 over 5. So whether you factor the 15 out, or whether you factor 3 out and then cancel, you get the same thing still. So 3 over 5, a minus 1. That's all you can do, believe it or not, for that one. Again, I made sure that some of the problems here were actually very simple. Because it's not always like, everything's going to drop off and you're left with like 3 plus 7. Or, sorry, x plus 7. Or sometimes you're left with just a numerical answer. But for these problems, you could be left with something as simple as that. Now, on the SAT, the answer might look like this. Those are the exact same things. Okay, again, if you distribute the 5 back out, there's really no difference. If you go on to study engineering and technology, you're going to learn that the denominator really needs to be factored, because there's a certain thing about this denominator that will indicate something. But again, until you continue to study that, you're not going to see this over again. But I'm trying to show you guys that I would leave it like this, because it's good to know what that value is. These are called the poles, by the way. Remember how when we set the factor equal to 0, it's called the roots? We solve for the roots of the equation. The poles are the opposite. The poles are what cause the denominator to be 0, or what causes this to be undefined. So later on, if you look at, for example, electrical engineering, you study poles and roots. This would be an example of that. But this is also an acceptable answer. And I want you to understand that. Just because your answer doesn't appear as a multiple choice selection on the SAT, it does not mean it is incorrect. It might mean, though, that you have to go back and change something about it. So maybe, as we just showed there, you need to distribute. Okay? Questions on that one? All right, other questions on the front page. So we're talking 1 through 6. Okay, let's go to the second page. Seven, 8, 9, 10.
Yeah,
Which ones?
all of them.
Okay.
Let's start with 7.
Mind if I do them quick, Julia?
Yeah, go ahead.
Numerator, 2, x plus 9. Denominator, x plus 9, x plus 2.
Why does yours
Cancel.
Hey, our number 7 is different. You have a different problem?
Really?
Yeah.
That's great.
You're probably using the other.
Oh, no, hold up. I know one. Give me a sec.
You still do?
You have it on.
Yes!
They're separate, they're different homeworks. Is that your number 7?
Yeah.
Yeah.
Is that better? Okay, now I see why the question. Number 7.
You can
A lot of people think that the numerator, you need AC method, but you don't. Everything is even in the numerator, so factor out a 2. Right away. The numerators start with 2v squared plus 5v minus 24 all over 8v plus 8. Again, 8 quantity v plus 8. You always factor out your GCF to start any problem. Now at this point in time, factor the numerators quadratic. What does that factor into?
V plus 8 and V plus 3.
Very good. This is v plus 8, and this is v minus 3. Again, so replace that with v plus 8, v minus 3. And then you're going to see the v plus 8's cancel. For a lot of these kinds of problems, especially on the SAT, if you have a factor in the bottom, there's a good chance it might appear on the top, or vice versa, so that you can cancel. So whenever you're going to simplify something, see how this v plus 8 was in the bottom? That's a clear indication that I'm probably going to have a v plus 8 up top if there's going to be some sort of a simplification. And it turns out I do, and I simply see that this cancels with this. The 2 and the 8 reduces to 1/4. Across this, put a 1. Across this, put a 4. Okay, finally in the bottom, all you're left with is a 4. Up top, all you're left with is v minus 3. So your answer is v minus 3 all over 4.
So, my little brother just looked up. It was like, 3 and like another quantity. So, and like at the top one's like,
You got it?
yeah.
Sure. Now, what's another way, this is a tricky question here. What's another way this could appear as a multiple choice answer on the SAT? How could I rewrite that answer in another form? It's the same exact answer, but it looks different. Okay, sure, I could theoretically do that, but you would never see that because that's not simplest.
Switch the sign.
Not switch the sign. How else can this appear as an answer? What's another representation of the same answer? How can I alter this so it may appear differently? Okay, Vicky says v over 4 minus 3. There's one thing that's wrong about that. Okay, stop.
Over 4, or 3 over 4.
Over 4. Very good. Again, if you want to, and you have a monomial in the denominator, this only works with a monomial, you can divide it into every term in the numerator. Again, since the 4 is in the denominator, you can divide this 4 into the v, and then take the 4 and divide it into the negative 3 also. Now, I can write that even more differently now. What else could I write it as? This is one choice, that's correct. Give me another way to represent it, based off of the one we have there. How can that then be changed? When you divide by 4, what are you really doing? 5. What's the reciprocal of 4? 1/4. So this is really v times 1/4. So I can write this as 1/4 v minus 3/4. Give me another way to write it. There's one more way I can see easily. What's 1/4 as a decimal?
Oh,
And what's 3/4?
0.25.
So this could be 0.25v minus 0.75. We just listed 4 answers that are all identical, but any of them could appear. Not more than one of them, though, obviously. They would never have the same correct answer in 2 different forms. Only one of the 4 would appear, but take a look. Again, we got one answer. This is a standard SAT problem right here, where it says simplify. And a lot of people try to cancel the incorrect way, where they try to cancel add-ins. And we know you have to have factors to cancel. Once you get to this point in time here, you can then go to any of those 4 forms. So please, when you're taking the SAT, consider the fact that your answer may be right, but it may not look right. You may have to alter it in some form. Okay, those are all correct answers, all 4 of those. But one of them is the only one that's going to be showing on the actual SAT multiple choice section. Again, a grid-in, this would not be your answer because there's a variable. So this is not a grid-in kind of problem. Remember, grid-ins have numerical answers. There are no variables there. Okay, that's number 7. I'm not going to do the next few, but let's go over at least one more of them. Can we do an AC method one, and then we'll do one of the challenge ones. So pick one of these 3 you want to do. Well, let's take a look quickly. 9 is AC method. 8 is not AC method. 10 is not AC method either. 9 and 10, you just have to factor out your GCFs correctly. That's all 9 and 10 are. Those would be 2 seconds. We can do those real quick. Number 9 is AC method. Let's quickly look at just the numerator of number 9. And I'll leave the denominator to you. So in the numerator, AC is going to be negative 30. And B is going to be negative 1. Do we all agree with that? What numbers multiply to give you negative 30 and add up to negative 1? Negative 6 and 5. Again, think of the factors of 30. The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6.
How you get negative 30?
AC is 2 times negative 15. So these are the factors of 30. Now, in some form or another, just add or subtract them. Take a look. When you add this, you get 31. And when you subtract it, you get 29. So that's not it. Add these together, you get 17. Subtract them.
13.
That's not negative 1 either. Add them together here. 13 or 7. That doesn't work either. Here, though, you get either 11 or you get 1. Well, take a look. How do I get a negative 1? By applying a negative sign there. You see how this works? I always do this. I never list my negatives and positives in the beginning. I just sit there and add and subtract them to see if I can get this value. And then when I realize I got the value, and I notice I need it to be -1, I put the negative on the 6 to make it -1. If I put the negative on the 5, what would this b have to be? +1. Okay, so these are my terms that I'm going to break the middle term into now. So the middle term becomes 2x squared plus 5x minus 6x minus 15. And again, if you switch the 5x and the -6x, it has no effect on the problem. And we showed that yesterday. Okay, at this point, what do I have to do?
Divide.
Split it in half.
Split it in half.
And here's
Split it in half before the sign, please. What's your GCF for the first two terms alone?
X.
Just x. Very good, Juliet. And you're left with 2x plus 5. Now, if I have 2x plus 5 in that parentheses, what must the other be? So you already know what you're going to have here. So please start by putting 2x plus 5 over here. Now think to yourself, what must I factor out to get 2x plus 5? Not just 3, -3. Again, this is where it gets tricky. See how these were both negatives? What do I want them to both be? Positives. Let's do it again. Again, the -6 and -15. These are both negatives, but I want to have a +2 and a +5. So I must factor out a -3. That's how you know what to factor out when it's negative or positive, just by looking at the parentheses and making sure they match up. So your final answer is what for this numerator? What does it become? What are the factors for this?
X minus 3.
X minus 3 and 2x plus 5. Again, you take the GCFs, circle your GCFs, they become one of your factors. Again, your GCFs become the first factor, doesn't matter which, and then one of your other two that repeats itself becomes the second factor. So that's your numerator. Now, based on your numerator, you could take some good guesses of what the denominator might look like if you're going to think about cancellations. I'm going to leave the denominator for you to work on. Now, numbers 8 and 10. Numbers 8 and 10, please don't let these deter you because they're such large values. So w cubed, the next to the fourth. Look for your GCF. It makes it so much easier. With that said, let's go ahead and take a look at those two quickly. Okay, we're doing fine with time. Today's a very short lesson, so. For number 8, numerator. I want one person tell me the numerator. Raise your hand. What is the GCF? The numerator. Okay. 9w. Very good. 9w. Not just 9. Make sure. Very good. So we're left with just the simply w plus 9. Again, where do I get that factor? How do I know it's correct? Well, I can redistribute it, and then I get 9w squared, then I get 81w. That's one way to do it. What was the other way to do it that I showed you yesterday, or reminded you about yesterday? No, I mean, how do you know what's left over, Trayvon? That's my question. My question is, when you take out the 9w, how do you know it's w plus 9 that's left over? What was the way I showed you yesterday? No. The signs will indicate what the sign should be, but that's not how you know it's left. You could always think about redistributing, that's fine. I told you a trick yesterday. Earl? Sure, if you can't break it down anymore, you know your stop. But my question is, how do I know that this is w plus 9? Where did that come from? Besides doing the undistributive law or thinking about what to get back to, how do I know what to fill in that blank after I take out the 9w? It's a very simple way to do it. How do you know that, though, Juliet? You're not answering the question. You're saying, I know what the answer is. How are you getting the answer, though? Explain to me your thought processes. Okay, how do you know what's left over? You see that you're not answering the question, though? You're saying that I just know what's left over. How do you know what's left over?
The remainder.
Not by multiplying, not remainder. I can tell you, but we've gone over this before. I did it once earlier in the year. I don't remember yesterday. By doing what?
Dividing.
By what?
The 81 by 9 by that outside number.
Good, you divide each of these terms by the GCF. Lucky guess there, guy. You think in your mind.
That's my point.
I didn't hear you guys, and I didn't see your hand up.
Now,
Yeah, listen right there. Now, whatever your GCF is, think about dividing by the GCF. So please, if you didn't answer that right away, just write it down, okay? Because a lot of people get confused here. You're dividing by the GCF. Okay, that's how you take something out of there. That's all you're doing. So what are you left with? 9W squared over 9W, you're just left with the W there. 81W over 9W, you're just left with a 9. The W's cancel. Okay? Again, I know a lot of you can do this instantly. I understand that. But my question was, how do you do it? And how do you know what you're doing is correct? That's how you know. Denominator, what's the GCF in the denominator?
9. No. W.
What's in everything?
W.
Just the W. Again, look at the denominator. It looks like there's an 8 and there's a 9. What might be the factors of that? But all I care about is the W that's there. Okay, the W is that the one that's important. It's in every term. And notice my W will cancel with the numerator. I'm left with W squared plus 8W minus 9. What do you think one of the factors of that might be? Look at the denominator and then look at the numerator before you even try to factor. What might one of them be? W plus 9 might be one of these factors because it's up top. And turns out it is W plus 9. And the other one is W minus 1. Okay? And again, try whatever you see up here as a factor and see what the other factor would be. There's a good chance it will occur in both spots. Cancel, 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 cancel. You're left with 9 over W minus 1. Now, for this problem, you cannot change that at all. That's it. You can't divide into the numerator like we did last time because the denominator is a binomial. In the last problem, the denominator was a monomial. When you have one single term, you can divide it into everything. And that's how we wrote all those different solutions last time. But here, this W minus 1, you cannot divide it into the 9. And you can't try and divide the 9 into each of those. So you stop there. Okay? I'm going to leave you number 10 just because it's very similar to number 8. You're going to factor something out. Okay? Be careful on number 10. Your factor that comes out might be a little larger. Quickly for the challenge. For challenge 1 was the easier one, obviously, just by looking at them right away. Can somebody tell me what they did for challenge 1? Split what up, Anthony? Okay, how did you split the numerator up, though? It's cubed. How do you do that? Okay. Well, there are several ways to do it. There's a method called grouping. I thought maybe you were about to do that. I haven't taught that yet, though, so I thought maybe you knew it ahead of time. What could you do? Use a synthetic table? Okay, use a synthetic table. That's a good way to do this. Using the synthetic table, you can find the roots, right? And then if you know the roots, you might also know the factors. And that might not work, though, remember. The roots are not always the same as the factors. We talked about that last class. So if you have, like, 6 as a root, the factor would be x minus 6. So you have to try them out and make sure they work. When you use a synthetic table, Luis, what did you start with? Yeah, what number on the outside did you start with? 1. Did that work? Okay, what did you try next? Did that work? Next? Okay, did that work? All right, so negative 1 worked as a root. So what would the factor be? X plus 1. So already, the numerator might have an x plus 1 in it. Now, how many more do I have to have? 2 more, because it's cubic. So at this point, you probably had a line here, right, Luis? And you made a quadratic from that? What did the quadratic become? Minus. And that factors in x minus 4, x plus 2. Okay? So x minus 4, and then x plus 2. Now, there's your numerator up top. What's your denominator an example of? Difference of 2 squares. Very good. X plus 1, x minus 1. And take a look. Cancel, cancel. Your final answer is right there. You can't go any further. Okay? Dots. Now, for challenge 2, I'm going to leave that up to you. Try your synthetic table, try to find the 4 factors of each numerator and denominator, and see what you can do. That's why it was a challenge. I didn't go over this in class. I wanted to see what people might try. There is another method to factor the numerator up top, but we haven't gone into that yet. Okay? We will go through it, so don't feel like we're not going to do it. But the numerator up here can be factored by a method called grouping. Do you want to explain grouping real quick, or do you want me to go through it?
There's like 4 terms, you split it up into 2 different.
Like AC method. So everybody remember AC method? Try AC method on the numerator. Take a look at the numerator.
Does not work.
Well, let's just try it. In the numerator, what can come out of the first two?
X squared.
X squared. And when you have x squared come out, you're left with x minus 1. Over here, though, what can I take out only?
-2.
A -2. And then I'd be left with what? 5x minus 4. The problem with this, though, is that they're not the same here, right? Say it one more time. +4, thank you. But again, the same thing, again, it doesn't work. You're not going to get the same factors in each spot. Okay? So here, grouping is a technique that doesn't really help us. You could have, absolutely. That's exactly another way to do it. Take a look here, guys. If you know these, you could type it into the calculator, look for across the x-axis to get an idea of where the roots are. Okay, you can always do that. Other questions on the homework? Today's lesson is a continuation. Today's lesson is a joke compared to what we did yesterday. We're going to be multiplying and dividing, but it's simply factoring everything and just cross-canceling everywhere. That's all it is. So you know all the stuff we did yesterday with simplifying and factoring? We're going to use it again today, but in the form of multiplication and division. Okay, before we start though, who remembers? What is the definition of division? Multiplying by the reciprocal. That's subtraction, be careful. Okay? Multiplying by the reciprocal. So when you see division, whenever you have these problems, do not divide. Multiply by the reciprocal. Let's begin with that set. Luis? Yes, thank you, Luis, for reminding me. Guys, pass your test toward me. If you were not here before earlier and you want to see it real quick, pass your test toward me in this direction. You're going to have to hand it back in real quickly, look at your test. If you didn't get a chance to before. Again, quickly look at your test, and then pass it toward the front of the room. Guys, test.
Overlap. We don't give any more.
The case, Julia versus
The other class has lunch at that time.
I don't understand what's up wrong.
Any other tests? Going around once. Please write down your steps if you haven't already, people. Why, Jay? Why? No, and I can't give it if I do.
You have, you give me you have half an hour.
So, we got 4 steps today. And please, you don't have to memorize these. After you do this enough, you're going to see that it's just going to be second nature. So, to start, whenever an operation is division, we write it as multiplication by the reciprocal. That's your first step always. Okay, it's in parentheses here because it's assumed that you do that. Once you've done that, simply factor, cross cancel or vertically cancel any factors, multiply across, and then simplify or modify your answer if needed. And I put modify to go back to the idea of the SAT question. You might get one answer and it might not be a choice. Or maybe you have to multiply or distribute it out. Or maybe you have to divide that monomial denominator into the numerator. So again, whenever we're going to do this, we're going to think at the end, what is our choice here though? What could our choice be for this problem? And how can we make our answer look different if need be? So again, it's the same as yesterday really. You're factoring, you're canceling, but now you can cross cancel and vertically cancel. And I'll show that. You're going to multiply what's left across and then simplify or modify. For the first example, let's start with this problem. We have the quantity 3x minus 3x squared divided by the quantity x squared plus 4x minus 5. That whole thing is times, there's a times in the middle, times the quantity x squared plus x minus 20 all over the quantity 3x. Notice, what am I saying before anything? The quantity, the quantity. Whenever I represent a polynomial, so in the numerator here I'm saying the quantity 3x minus 3x squared divided by the quantity x squared plus 4x minus 5. That indicates that I'm stating a continuous thing. I'm stating that this x squared plus 4x minus 5 is all in the denominator. Okay? So you can write math, you have to be able to speak math also. In this problem, you're going to take a look and notice right away, there's no division, so we don't have to worry about that. So right away, what do you start by doing? Factoring. So start by just rewriting your fraction lines. And factor. Okay, where are you at? Okay, denominator in the first one. Go ahead, Anthony. Very good. Somebody else for the numerator now? Go ahead. Very good. That's a tough one. Okay, that numerator there. 3x, 1 minus x. Remember, if you take a 3x out of 3x, you're left with just 1. If you take a 3x out of 3x squared, you're left with the x. The numerator of the right side, an s?
X plus 5 and x minus 8.
Very good, and the denominator is still just 3x. Well, take a look. A lot of stuff starts canceling, doesn't it? Okay? So, our second step is to cross cancel or vertically cancel. Take a look here. This whole numerator is really multiplied by the whole numerator over here. So this is really like one big fraction line, actually. That's what I want you to be thinking about these problems as, where there's all multiplication signs between everything. These are all factors now. So that's why cross-canceling is allowed. Again, because this is really like one giant fraction line. Because multiplication of fractions is multiplying the numerators and multiplying the denominators. So at this point, it's pretty much one fraction. So your x plus 5s, yes, they cancel. The 3x's, they cancel. Be careful, though. They don't cancel right away, but they do have a special technique we can use here. Does anybody know this one? Can we switch them? So like switch to 1 minus x? If I were to switch them, what do I have to multiply by? -1. Very good. Let's go through this. God bless you. Here, watch what I do. Factor out a -1 out of here, please. So hold on, let me just make this cleaner. Let me write on the next line. I'll be right where we're at. So right now we're at this point. This is where we're at. That's what's left. Now, our goal right now is to cancel the x minus 1 and the 1 minus x. So Vanessa already noticed. In the numerator, in the numerator here, we see that we have 1 minus x, but we want x minus 1. 1 minus x and x minus 1 are opposites of each other. So just apply a negative sign out here and switch these two. And let's show how that works. So if I factor out a negative 1, I'm left with negative 1 plus x in the numerator. Again, if I were to factor out a negative 1 out of just this left factor here, I factor a negative 1 out of this, I'm left with the opposite of those signs. But take a look. You see that it's negative 1 plus x. That's the same as x plus negative 1. Still with the negative 1 outside, all over x minus 1. Again, notice, this negative 1 plus x is the same as x plus negative 1. X plus negative 1 and x minus 1 are now the same thing. Again, just so you can see where we started with, up there. We started by factoring out a negative 1 out of this term. When you factor out a negative 1, the signs must both switch. So this sign becomes a negative. This sign negative here becomes a positive because I factored out the negative 1. Again, I'm not concerned about the x minus 4. Now I notice that this is negative 1 plus x. That's the same as x plus negative 1. Because remember, addition is commutative. 5 plus 3 and 3 plus 5 are the same. So here, I switch the order of them now. And I see that I have x plus negative 1 and I have x minus 1. Those are identical. So whenever you cancel something that is switched, just cancel and leave behind a negative 1. Again, your rule to go from this. You do not have to do this every time. I don't want you to do this every time. If you ever have something that looks like this, let's say 2x minus 5 over 5 minus 2x. Okay? Those do cancel, but they result in a negative 1 because they're in opposite order. If you had y minus x over x minus y, that's a common one that's on the SAT. And you know what? People get confused. This is your final answer, and that's not a choice. But the final answer choice is negative 1 because these actually cancel and leave behind a negative 1. Again, whenever the numerator and denominator factors are switched and there's a minus sign in the middle, you would cancel them and leave behind a negative 1. Normally you cancel and leave behind a positive 1 because they're switched. Ashley. That's correct. Anytime you have a problem, so just to give another, so the final answer here is this negative 1 and this x minus 4, just to finish this problem. So we have negative 1, x minus 4. Now there's really a 1 on the bottom, yes, because this results in a 1. But a 1 on the bottom means nothing. Like 5 over 1 is just 5, right? You can leave it like that, or you can write it as negative x plus 4 if you want to distribute it. Either way is fine. Again, either choice is possible on your test. Okay? Now, let's look at an example again of this before we get into division. What if we had, let's say we had x squared plus 8x plus 15 all over 5 minus x. Oops. Let's say not plus 8. Let's say minus 15. And let's say minus 3x, like that. Let's take a look at this one. And this is a simple problem. It's not multiplication, just simplify. Again, start with your first step with the GCF. Oh, there's no GCF. Go to the second step, which is just factor. So go ahead and try and factor this, please. What should this middle term be? Who noticed? Thank you. Fix that. Make that a 2. Who was that? Juliet? She noticed right away there was nothing there? I'm sorry? We're not multiplying. I'm just saying simplify, guys. Just simplify. We're just practicing the last rule. That's the only reason I'm doing this. Numerator, what do you get? X minus 5, x plus 3. Very good, Anthony. The denominator has a 5 minus x. So what do I do to those? Cancel them both and leave behind a negative 1. It doesn't matter where you leave it behind. You can leave behind the negative 1 up top, and then you leave behind a positive 1 down below. Or you can leave behind the negative 1 down below, but then you need to leave behind a positive 1 up top. Either way, your answer is going to be negative 1 times x plus 3, or you can write it as negative x minus 3, which would be the same answer either way. Even if you have the negative down below, the negative divides into both of these, doesn't it? And it becomes this answer right here. If you had the negative up top, it just looks like this answer right here. Either answer are the same. Number 2. Number 2. What do you see we have here? Division, so what do we do? Multiply by the reciprocal. Very good. Which one are we reciprocating? First or second? Good. Only the second one. Remember, the first term stays the same. Okay? The first term, or the first, in this case, factor, because we're going to turn it into multiplication, so it is a factor. That first factor, you leave it alone. You got to flip the second half. So just start always by rewriting your problem. If you want to, and you can factor in your head and flip at the same time, feel free to. I'm not going to do it this time, just to show the steps. Again, you could have factored that already in your head and shown the work for yourself there. On the left side, 7x I leave alone because I can't reduce it. Denominator, GCF is 2, leaving me behind with? Very good. Numerator. Good. Minus 5, minus 6. Brandon and Anthony. Very good, guys. Minus 5, minus 6. Denominator. Factor out the GCF. What is it? Just x. Very good. Leaving behind? X minus 6. Again, all these things seem to work out sometimes, right? Again, when it's on your SAT, chances are a lot of stuff is going to cancel because your answer choices are very simplistic. So you're going to see all this cancellation here. What's your final answer? Anybody?
6, so basically 7 over 2.
7 over 2. No, just 7. The x's cancel also. Be careful. You got x up top and below. Okay, again, this x cancels with this x right here. I'll circle them so you can see. Those cancel. Then the x minus 5's cancel, and the x minus 6's cancel. Remember, this is cross-canceling what we're doing here. We're cross-canceling it vertically. Very good, which is 3.5. So as an answer choice in the SAT, imagine being given this problem, seriously, and your answer choice is a number. I guarantee you that they'll make like 3 of the choices variables. And a lot of students, if they're guessing, will guess the answer choices with variables because it started with variables, so shouldn't it end with variables?
No.
But everything happened to cancel here. So again, be careful. You get a numerical answer for something like this. Think about it this way. This could be a gridding because the answer is a numerical value. This could easily be a gridding, okay? And it would confuse a lot of people because of the fact that they see the x's. You know what some students would try to do? Who can tell me what they were trying to do here? Think about the common mistake.
They probably combine them.
They could combine them, sure. Good.
They would just call it bad.
But think, guys, think for a second. The answer has to be a number. So what might some students try to do to get a numerical answer? Because it looks like you can't get a numerical answer at first.
Cross up
They might try to find roots, that's one thing. Plug something in for x, okay? There's one thing that you're all missing that I see a lot of people do. And I've seen some of you do also. Some people do this. They see 2 fractions. When you see 2 fractions, you think about proportions usually. And if there's an equal sign, don't you cross multiply and set them equal? Some students will try to cross multiply, set them equal, and solve for x because there's a numerical answer. That's another way. No, absolutely not. Again, cross multiplication works when you have an equation. This is an expression. Again, this is an expression. They are multiplying or dividing. There is no equal sign. Thus, there is no equation. Therefore, you don't actually solve for x. This is not what x equals. This is what the expression reduces to. This is, again, not what x equals. We are not solving for x because there is no equation here. Number 3.
Oh my god.
Again, you stop for a second. This is an SAT problem I actually pulled for. Good, so start by flipping the last one. Start by flipping the last one. Factor everything and cross-cancel all you can cross-cancel. Try this on your own.
This is
What are you going to have to use? What kind of method here? AC method. You're gonna need AC method twice. You're gonna need dots. So you got a lot of work to do. I'm gonna give you a minute to simplify the first fraction here on the left. A minute for this first one. Go.
Don't time us, that's.
Just for the first fraction, work on first. I'm gonna put up the answer in a second. That's why. You're gonna have a minute.
Just write it down.
You got 50 seconds, Jimmy.
Imagine sitting in the SAT. Early in the morning, at like 9 o'clock. I know, you're tired as anything.
Did anybody print the notes out ahead of time?
I
No? I'm trying to type. You gotta correct it before you print them out.
Oh, my.
15 seconds.
What?
The numerator should be done like this. The denominator takes a little while there.
I got the denominator right here. You know what I mean? I got a problem.
Anybody got the denominator?
Oh, I already.
Anybody complete the AC method?
I don't have space. What is this?
Didn't it add nine?
Sure, but what are the factors become? Keep going. You gotta break it down, go down the middle, draw your line. Practice makes perfect.
You sound like a robot.
I have no idea. I'm telling you, you need to get factors, Julia. That's what I'm telling you. Should be that. What do you get for factors? Guys, you need to start timing yourself and working really fast on your homework. I'm not saying it's careless, but you need to practice this stuff.
Oh, AC is 3 and 24. It's 3 and 24. You want to bet $1? So it's not even that. I thought it was. That's equals 17. That's equals 17. Like I said, it's
I thought it was multiply to 72. And then subtract. I mean, add up to 17.
Check your answers, please. The work is at the top. If you want to see the work, factors down at the bottom. The work is up top for that one. AC is 72, B is 17. 8 times 9 is 72. 8 plus 9 is 17. Okay, split up the middle, it's 8 and 9. Factor out the 3x. If you did it backwards, it doesn't matter. You get the same values. For the second one, the denominator you should all be able to see right away. What are the only numbers really that you use for 28? There's a few of them, but what are the main ones? 7 and 4. And right away, 7 and 4 can give you 3. Okay, x minus 7 and x plus 4. So the denominator should be simple. The numerator, give yourself a little time now. The numerator, you got to do AC method again. Please tell me what you get. Absolutely. So see how here, what can you factor out? See 12x, 8x, I see 2x. 4x. So what comes up? Can you just erase the last one?
Like she always does.
Here. GCF is 4x.
I hate it. It's cool.
Yeah, I know, right?
It's not.
To make it 21 and 2.
Why do you need this shit?
Shut up.
Oh,
yeah, got it. Everybody else got it. I got it.
You just said it.
Bro.
How you write that? Huh? How you write it? Write what? Oh, I got you. All right, look at this. All right, John goes 3x squared minus 42x. Oh, wait. Minus 21x plus 2x minus 14. Oh. And then it goes 3x plus 2x.
John, you got me messed up.
Second answer.
Second answer.
What? You answered.
Even then, she only gives me negative 21 times.
What? Trevor, shut up.
Uh-huh. They got a mistake in the test and it's like, word. Okay, the numerator here.
It's not mathematics.
You end up getting x minus 7 and 3x minus 2. Oh, sorry, 3x plus 2. Now, if you want to see the work, I will quickly put it up. AC turns out to be negative 42. B is negative 19. The numbers that give you that are going to be 21 and 2. Which one of them is going to be negative? The 21, because we want a negative sum. So 3x squared minus 21x plus 2x minus 14. In the first two, I'm going to break this down. I'm going to factor out a 3x. I'm going to see that I'm left with x minus 7. And here I'm going to factor out a 2, and I'm left with x minus 7. 3x plus the 2 gives me the 3x plus 2. X minus 7 gives me the x minus 7. The last line, you're going to flip it, obviously, but you're also going to factor at the same time. So do it all in one step, please, in your head. So the bottom would factor into x plus 5, x plus 2, so I'm going to put it up top. Again, the bottom would factor into x plus 5, x plus 2. I'm going to put it up top because it's multiplication. The numerator would have factored into x minus 4 and x plus 2. So I'm going to put it down below. And now begin the cross cancellation process. The homework for tonight, you're going to notice a lot of stuff cancels here. 4x plus 3 does not cancel. Sorry, that's the only one that doesn't. Whoops. Cancel, 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 cancel. X plus 5 over 4x plus 3. Before you leave, take your worksheet. I thought we were going to do a classwork assignment today, so if you want more practice, I've got a whole set of classwork practice ones here. This is your homework tonight here. Okay, if you want more practice, please ask me. You can get more. I thought we'd have a little more time. Can you get what? Yes, the practice one is right there also. Just take the binder clip off. You can take a practice one also. And this is the same thing we did yesterday. It's no different. This is the homework. Practice is on the table. Homework's coming out. Guys, fix your desk before you leave. Clean up around you. Practice on the table. Here's the homework. Oh, man. Homework's in my hand. Practice on the table. A lot of you need more practice, so I recommend taking that practice worksheet. Jason?
I gave him one.
This is the homework. That's the binder. This is the homework?
Homework's right here.
You said that, is that your binder? That white one?
Yes, it is. It's